Okay. Now we're going to go through the questions in paper 1 for our Prelim 2 2015 paper. So the questions I got is question 9, 11 to 14, 19, 20 and 33. So if these are not the questions that interest you, you can skip this video. So I repeat, we are doing question 9, 11 to 14, 19, 20 and 33. Okay, let's begin. Question 9. Okay, let's go to question 9. Okay, here's question 9. Pretty simple. We are supposed to choose mass and weight. So what is the issue here? Okay, I think mass is quite obvious. These are the correct ones. For the weight, definitely it depends on location because the weight is given by the formula W equals to mg, and this g here, actually it depends on, of course, the planet. Sometimes if the height difference is drastic, it will also depend on the height. I'm not saying that you will weigh less if you climb to the 12th floor. That kind of height, it is still not drastic enough. What I'm saying is like on sea level compared to the top of Himalaya, that kind of height difference will have a small effect on the G. So strictly speaking, the weight will depend on the location. But if we are just talking about roller coaster ride and things like that, we take G as constant. But if you look at this question, I think it tests you specifically on this piece of content knowledge, that G depends on your height from the center of the earth, or well, if you go to the moon, the G also will be different. So therefore, the answer is 9. The answer is A. So now question 9 is done. Let's move to question 11. Okay, question 11, you need to use a little bit of algebra, and personally I do not like fraction. So therefore, once I see fraction, I will change it to 0.1 L. Down here is also 0.1 L, and this guy here is 0.2 L. Okay, so after changing everything to decimal, I need to look at the question's context. So down here you can see that there's a very important keyword, uniform plane. Now, what is the implication of this? The implication on this is that the CG of this plane will be at 0.5 L. Okay, and because it mentioned uniform plane, we cannot ignore that this plane has weight. So you know that there will be one more force down here, and because of this force, you are going to complicate your calculation. So how do we get rid of this? How do we not include this weight component in our calculation? Is that we can decide to take moment about the center of gravity. So notice what I said in my words. I will take the pivot. I will take moment about the pivot such that the pivot is at the center of gravity of this uniform plane, meaning that I will take my pivot at 0.5 L from one of its ends. Why is it that I want to do this? Because if I put my pivot there, then the weight of this plane will be directly above the pivot, and because of that, I do not need to consider the moment caused by the weight of this plane. So therefore, in this whole calculation, I will take pivot at the CG. Now, once I do that, now I look at the question. The question now says that my Y has been now shifted to 0.L from the right. So meaning that now my Y is no longer here. My Y is somewhere over here, and it is 0.2L from the edge. Now, since this question obviously is about rotation, therefore it is about moment. The distance that I'm interested in is from the force perpendicular to the pivot. So therefore I am interested in this distance. So I'm interested in this one. I'm interested in this one. Now you can see the advantage of using decimal. If I use decimal, I can quickly work out that this guy is 0.4L and this guy here is 0.3L, right? Because down here it is 0.5L. Now, in order for this plank to be balanced, it means that my clockwise moment must be balanced by my anti-clockwise moment, and so this force here will give rise to a clockwise moment. This force Y here will give rise to an anti-clockwise moment. I know that these two must balance, so I just need to write equation on that. Okay, so I'm going to open up a new program so that I can work with all these numbers. Yep, it's my favorite pain. So I will write clockwise moment must be equals to my anti-clockwise moment, and let's take a look. Okay, my clockwise moment is from X, so I know that my X is my force. I must multiply by the distance, which is 0.4L, and down here will be my Y. It is 0.3L. So you can see that the L can cancel off each other. So I'm left with 0.4X here and 0.3Y here. And the ratio that I'm looking at, this guy here, I'm using my cursor to point to you, is a ratio between X and Y. So I want to have X over Y here. So I will bring my, actually what I did is that I bring this Y over to here. Therefore this 0.4 I need to bring over here, and therefore it is equals to 3:4. So therefore my answer is 3:4. So I should choose this guy over here, C. Okay, let's on to question 12. Now question 12 tests you on the understanding of stability, and you know that stability is basically whether an object will topple off due to its own weight. So I know that this diagram is very hard for you to perceive what is happening, so it is better to draw a side view. So this is the can, this is the floor, and you have a toothpick here and another toothpick here, and then after that you have a fork that is going this way. Okay, so just by drawing this, you know that if now your D is here, what will happen? If your D is here, that means your weight will be somewhere over here. And as you can see, if let's say now I don't consider the can, I'm only looking at my toothpicks. Okay, and you can see that my toothpick has a really small base area. So down here is my base area. And if my CG is at D, you can see that if at D, what will happen is that I would have a anti-clockwise moment, and therefore this whole thing will topple this way. So you know that D cannot be your answer. So now you are only left with A, B, and C. So you can see that, let's say you are at, let me choose another color. Now you have A, B, and C. Now, using the argument previously, if your CG is at A, B, or C, the weight will be still within the base area. So actually, if your CG is at A, B, or C, the thing won't topple. So meaning now you need to have one more argument so that you can confirm where your CG is, whether it's at A, B, or C. Let's do the easy one first. Can it be at A? Now, if you look at the whole system, that means the can, the toothpick, and the fork. If you are just looking at the toothpick and the fork, you can see that most of the mass come from the fork, correct? The fork is definitely heavier than the toothpick, meaning that the CG will be heavily influenced by the position of the fork. And you can see that most of the mass of the fork is towards the bottom. So you know that the CG would not shift up because there is very little mass above this toothpick, right? So you know that A cannot be the answer, right? And if you look at right here, B, same argument. Most of the mass is below the toothpick. So therefore the CG cannot be on the same level at this toothpick. So because of that, you look at C. C it is correct because like what I said just now, most of the mass is at the bottom. So therefore the CG will be heavily influenced by this position of this bunch of mass right here. So therefore C is your answer. Okay. Now if you do not understand what I mean by the CG is heavily influenced by the mass, I will give you another example. So look at the screen. So let's say I have an empty tin. Okay, a tin box. Now because it's empty, the CG will be right at the center. Am I right? When it is empty, this box. But now, if this tin, I fill it up with maybe some oil to this level. Now the oil itself will have a mass. Agree? So the mass of the oil will, let's say, be at this point. Not let's say, it's geometrically able to determine. So the mass of the oil is this green color cross, right? And if now I want to treat the oil and the tin as one entire system, meaning that now my CG, I need to take average. Now the black color one is the CG of an empty tin. So this guy is CG. Oops, why can't I write anything? Oh, okay. This is the CG of the empty tin. And this one is the CG of the oil. And if now I want to treat the oil and the tin as one body, then I need to take the average of these two. Okay, and because you know that the oil is much heavier than an empty tin, the average position of these two CG will be inclined to be towards the bottom. It will not be at the center line here. It will be slightly towards the oil side because the oil is the heavier body. So that is what I mean by when most of the mass is at the bottom, the overall CG will also be towards the bottom. Okay, let's move on to question 13. Question 13, right, is actually what do I say? It's like a mathematic plus wordplay. Now what I mean by that, we all know that power is given by this formula whereby E is energy, time is the time. So I think most of you will agree with me, A is definitely correct. Same thing as B. Okay, the amount of energy converted, like 100 watt light bulb, it means that 100 joules of electrical energy is turned into 100 joules of light energy within a second. So we know that B is correct. Now the problem is with C. Now they say that it's a product of constant force. So force is given by this, and its average speed. Speed is given by this. Now, if we simplify this expression, force is still force, but speed is given by distance over time. It means that this expression, it can be now simplified to this. Now, what is force times distance? Force times distance is work done. And so you can see that now my simplified expression, W over T, is the same as the power formula. And so your part C is correct. Yeah. So with all this, A, B, and C are actually all correct. Let's look at D. D says that it's the product of mass of a body and its acceleration. Isn't that mass m times A, that will give you net force. That is not power. So if let's say you are choosing between C and D, and if you have no idea what C is, then you do by elimination. You know that A and B is out. It is the correct definition of power. And then you look at D. D is mass times constant acceleration. That gives you net force. So therefore, you will naturally choose D1. So for those who choose C, you are just stubborn. Okay? When it is exam, don't be stubborn. Play smart. But as for life itself, it is good to be stubborn. As a scientist especially. If something bothers you, ask. If something bothers you, go and check it out. But in exam, don't be stubborn. Go street smart. Okay, now let's look at question 12. Question 12 is about your pressure. So pressure is actually quite simple. You just look at the pressure at a water level that you want to focus on. So naturally what you will do is that, okay, now you look at the question first. You want to find the gas pressure of this supply. So how do? You want the pressure here, and this pressure is pressing against this water level. So let's use this water level as our reference. Okay, so you know that this pressure will be translated to here, and it will be used to support the weight of this column and the atmospherical pressure. So they already tell you the atmospherical pressure here is 76 mm mercury, and you can work out what is the pressure of this column, and the pressure of this column is just 15, which is this height, 15, minus of the 7 cm. So this is 15 minus 7, that will give you 8. And so this pressure here, which is actually equals to this, will be equal to this pressure plus this pressure. 76 plus 8 will give you 84, and that is how you work out the answer. Okay, now we move on to question 19, and you are asked what is latent heat of fusion. Isn't this definition? Okay, it's not definition, it's understanding. What is it used to? Is it used to increase kinetic energy of the molecule? Definitely no, because if you increase kinetic energy, what will happen is that you will also be increasing the temperature. So this guy here has an implication that you are increasing the temperature. And when you are talking about latent heat, you are talking about a change of state. And you know that a change of state does not involve temperature change, and therefore A is wrong. Same thing. For B, it will not change the kinetic energy, and definitely nothing to do with electrons. So you know that B is wrong. Let's look at C. Okay, work against surrounding atmospherical pressure. Let's say you are doing the exam, you are not really sure whether this is correct. So let's leave it hanging first. You look at D. The work to break the binding force between molecules. To do the work to break the binding force between the molecule. Yeah, it is. It is. It looks like it is correct, but look carefully. You are talking about, you are talking about fusion. Fusion means that you are turning solid to liquid, and in liquid there is still intermolecular forces. It is not like gas. In gas, you really break the intermolecular forces. That's why the gas particle can go freely. But in liquid, they are just sliding over one another. They are still bound by intermolecular forces. So therefore, D is not correct as well, because it doesn't it is not breaking it. For fusion, it is not breaking. It is just weakening. But for latent heat of vaporization means from liquid to gas, then it is really breaking. That's why the gas molecule can now move freely around. So D is also not correct. Okay, so therefore you are left with C. And you will ask me, teacher, what's C? How come suddenly got atmospheric pressure now? When you are talking about, okay, focus on this. I'm not going to act it out. Let's say, let me open this thing. Oops. Okay. Let's say you are talking about latent heat of fusion, and you were just saying that fusion is solid to liquid. How is atmospheric pressure in play here? Now, if you look at an ice cube, in order for this ice cube to turn into water, it needs to expand. Am I right? Correct or not? Why is it that I say that it needs to expand? Because in solid form, the particles are in closed packed structure. In liquid, there is less closed packed structure. Correct or not? Meaning that in order for this to expand, it must push away the air particles that is pressing onto it. Correct? And because of that, part of the energy will go into doing work to push away the atmospherical pressure. So, strictly speaking, your latent heat of fusion, the energy required to turn solid into liquid, will be used to weaken the bonds, the intermolecular bonds, plus to work against the atmospherical pressure which is pressing onto the solid. So therefore, your answer is C. Now, why is this not mentioned in class? Because actually the portion to work against atmospherical pressure is very small, especially in fusion, especially in solid to liquid. Okay, because the expansion is really small. That's why it is not mentioned. But in this question, that is the best option that we can choose. When will it be significant? When it is liquid to gas. Liquid to gas, there is bigger expansion. It means that you need to do work. Work is given by force times distance. Because the expansion is a bit more, the distance that you need to push the gas molecules away will be greater, and so that part will become more significant when you are changing liquid into gas. Okay, and what is the implication to this? The implication to this is when you're answering structured question, and it is a structured question that has a lot of marks, then you need to mention that the latent heat of vaporization or fusion is not only used to weaken or to break the intermolecular bonds, but also to work against the atmospheric pressure. Yep. So let's move on. What question now? Okay, two more. Okay, your question 20. Question 20 is about calculation, I guess. To freeze. This question should not be a problem, you see. So anyway, since you are asked, I will help. What's the time needed to freeze water? So there are two parts to this. First, you must bring the temperature from 30 degree to 0 degree, and then you must freeze it at 0 degree C. So that's the amount of heat you need to remove. So to find out the amount of heat to remove, in order to bring down the temperature from 30 to 0 degree, you use MC delta theta. So the M is given, the C is also given, and you can calculate the difference in temperature, which is 30. And down here, to freeze it, you should use the latent heat of fusion multiplied by the mass. So the mass is the same. Latent heat of fusion is 3.36 times 10 to the power 5. So work these two numbers out, sum them up. That will be the total amount of heat you need to remove. And then the question gives you another information that the machine can remove 3000 joules of heat energy per second. So what you need to do is that you need to 3000 watt is equals to the amount of energy over time. So this whole chunk of thing goes into your E, and hence if you want to find time, you just take this whole chunk of thing divided by 3000. You should be able to get the answer. Okay, so I'm not going to calculate for you, do it yourself. Last question on MCQ, question 33. Here. Oh, graphs. Should be quite simple. Okay, some of you, when you look at graph and you look at unfamiliar graph, you have this fear in you. Actually, don't fear. It is all like mathematics. Just treat it as a math test. So, you're asked to find resistance. So, write down the formula for resistance. The grades are great. V equals to I out. Make out the subject. It will be V over I. Now, when you have a graph and you're comparing things, you need to fix one parameter as constant. I will show you both ways. Okay. Now, let's say I make V constant. Make V constant meaning that we are going to compare everything along this point because I say that this guy is constant. So I draw a line up. Okay. And I will have come on, give me the color. I would have 1 intersection, 2 intersection, 3 intersection, 4 intersection point here. So if I want the greatest resistance, meaning that I would want to have a bigger I or a smaller I. Obviously, because now my I is at the denominator position, I want this to be at minimum so that my R here will be maximum. So if I look at this intersection point, I will see that this line here gives me the minimum I. So I know that A will be the greatest resistance. Now, let's try another method. Let's see, I have everything the same. But now, for some reason, I do not want V to be constant. I decided to have I constant. So which axis must I fix my point? Yes, it is going to be at my y-axis because y-axis is my current is. So I draw a line. Okay, if you see that some lines are not intersecting, just extend it. So this is my B. My A will be somewhere here. This is my A. Okay. And if I want my maximum here, and V on my numerator position has also to be maximum. So, which line cuts at maximum V? Is it D, C, B, or A? Well, obviously, this point will give me the maximum V. And so, A is my maximum resistance. So, same thing as my previous argument. So, when you look at graph, it is unfamiliar, don't worry. Okay, write down the formula, make the parameter that you are interested in the subject, and then analyze and compare, okay, between the formula and try to relate it to the graph. The idea is don't panic. You all can do it. You all are good with mathematics. Imagine other students who have problem with mathematics. Okay, so just take a deep breath and analyze. Keep calm and analyze. Okay, so I think that's it for paper 1. Pause here.